Hi, welcome to this lab. In this lab, we're going to build and integrate an AI agent with a Flutter app using AI application. So this is the model that we're going to build today. In the task 1, first we will create a search data store and search app. So first we will scroll to the artificial intelligence. Yeah, this one, go to the view all product. And go to the AI application. Yep, this one. And then click continue and activate the API. Click on the data store and create data store. On this page, you configure your data source to be used for search result. The lab is pre-provisioned with a cloud storage bucket that contains a CSV. So we will select cloud storage, and then for the type here, we will select CSV. Okay, so go to the file and then browse for the lab bucket and select this file. And after that, press continue. Give a name to the store. Okay, let's call this and click create. Okay, click on the data store. Take a look at the document. This is how the document look like. Okay, so I mark my process for the task 1 is completed. Now we will create a search app. So back to the AI application. And we will create a new apps. We will create a custom search general. Disable the enterprise edition features, and for the app name, I enter a name here and the external name for the company. Location leave as the default. Click continue. So you see the existing data store display. Select the Google Merge DS data store you created and click create. The search app is created and the data store is connected to the app. To test the search app in the AI application, you can click this preview. Okay, so let's say we're looking for this book, Dino, and the result is out here. Good, and now I check my progress. It should be completed. That's good. So now moving on to the task 2, we are going to build and deploy the backend. The backend of our Flutter app will run as a Cloud Run service on Google Cloud. The backend service integrates with search app that you created in the previous step to generate the search response from the merchandise shop data. The backend also integrates with a reasoning engine agent to access Gemini for generative AI content in response to query from the Flutter app. So in this task, you will build and deploy the backend Python app to Cloud Run. So first, we will open a new browser. We are going to the IDE online to do the Python coding. Just to show you how it looks like. So this is the IDE. Okay, the IDE is open. We need to open a new terminal. I want to allow paste because I want to copy the initial version of the backend app folder and its content from the cloud storage. Okay, so it's done. Okay, I'm going to, still running, sorry. Okay, once it's finished, let's list out all the files inside. So you will see there's a folder called app folder that contains the application source code and other files need to build and deploy the backend app to the Cloud Run. Now we got to set the project ID location, staging bucket configuration for the app. Okay, now go back to the terminal. Do a login, authenticate first. Yes. Okay, so you have to follow this step. Open. Okay, copy this and paste here. And now we are logged in. Okay, so we are going to deploy these apps using this command. So we will make the deploy sh script executable and then run the script to deploy the app in the specified Cloud Run region. After the app is built and deployed to Cloud Run successfully, the app endpoint URL is displayed at the end of the script output. The URL was generated by the gcloud deploy command that was executed in the script. Well, this command will take some time to execute, so wait until it completes before we go to the next task. Okay, so finally it has finished deploy. So now let's open the URL. Says here, welcome to the web end. If I were to add this, I get an internal server error. For some reason, so we will move on to the task 3, configure Firebase. So to create the Firebase project, we will have to open a new Firebase project in the new query, a new browser. Okay, so we will create a Firebase project. I will accept these terms. Yeah, just accept and then click on the Add Firebase to Google Cloud project, and then we will select a Google Cloud project, which is this one. Continue, continue, and continue. Do you want to use the Google Analytics for this lab? We don't need that, so we uncheck it. Add the Firebase. Very quick one. The Firebase is now ready to use with our lab Google Cloud project. Okay, let's press continue. And now go back to our IDE to sign in into the Firebase. So they ask us to log in again, open the new browser page, choose the account, continue, allow. Yeah, that's my session. Copy this and paste. Yep, successfully logged in. Okay, now task 4, we're going to create a reasoning engine AI agent. So an AI agent is an application that uses the power of large language model for reasoning and orchestration with external tools to achieve its goal. Vertex AI Agent Builder is a suite of products and tools that Google that help you build AI agent by connecting them to your trusted data source. Vertex AI Reasoning Engine, known as LangChain on Vertex AI, help you build and deploy a reasoning agent with Vertex AI Agent Builder. LangChain is a popular OSS tool used to build chatbots and RAG systems. The reasoning engine let developer use function calling to map the output from LLM to Python function. Reasoning engine integrate closely with the Python SDK for the Gemini model in Vertex AI, and is compatible with LangChain and other Python frameworks. So in this task, you will use Vertex AI Workbench with a Jupyter notebook to deploy a reasoning engine agent with Python function. The agent will be used in our generative AI backend application in the next task in this lab. So back to Google Cloud, and now we will go to the Workbench. So Vertex AI Workbench is a Jupyter notebook-based development environment for the entire data science and machine learning workflow. Okay, let's create a new notebook, and I give this a name called my instance, and then click create. You can interact with Vertex AI and other Google Cloud services from within Vertex AI Workbench instance Jupyter Notebook. For example, Vertex AI Workbench let you access and explore your data from within a Jupyter Notebook by using BigQuery and cloud storage integration. Google AI Workbench instance comes with pre-installed suite of deep learning package, including support for the TensorFlow and PyTorch framework. Vertex AI Workbench Notebook provides a flexible and scalable solution for developing and deploying ML model on Google Cloud. Now, yeah, this is still developing. We will have to wait until it completed. Okay, it's done. So we go to open the Jupyter Lab. This will open a new browser. We will use the Python 3 kernel, and we want to copy the file from the Google Cloud, so just run this command. So this will copy the notebook to your Jupyter Lab instance. Yeah, and the name of the notebook is this one. Open it up. Okay, so we just run everything. And now I'm running this pip install. So after install the reason engine, now we will need to restart the kernel. Just wait for a bit. Yep, it will ask me whether I want to restart the kernel. Okay, the next one is this. We will replace with our configuration. That's correct. Run this. Yeah, it's done. Okay, let's continue here. Finish. Now move on to the next one. Define the two functions for the Wikipedia API. Our previous one is define function for accessing the Wikipedia API. And now we run this. Okay, so I got some result coming out, which is good. Okay, the next one is we will define the two functions for Vertex AI Search. Okay. Number 7, define the agent. So you give the model name and then what's the agent that you're going to use, and then we can test it locally. I suspected I got the error, but we will have to just move on to the next one. So we will deploy the agent. We will deploy the agent to the reasoning engine runtime. Even though there's some error here, I think it's because it says connection error. So finally, okay, let's run the remaining. Okay, so I still get error. I think it's the same error that we have last time. That is the connection error. Well, if I run the last one, I will also get the error. And somehow I get a return of a message for this without any issue, which is good. How about I change this one to Dino? Okay, so it's asking me to provide more detail. That's fine. So the reasoning engine agent has successfully invoked either the Wikipedia or the Vertex AI Search data store based on the query input and output from the Gemini model. Now we move on to the task file, enhance the backend app. So let's now enhance the backend app to invoke the reasoning engine agent that you deployed in the previous task. The initial version of the backend app only fetch result directly from the Vertex AI Search. In the new version, the app will invoke the reasoning engine agent that use the output from the Gemini and the agent 2 to generate a response from Vertex AI Search or Wikipedia based on the input prompt. So in this task, you will update the backend app code to add an additional entry point that invokes the reasoning engine agent with a request query and a return agent response. Now go back to the IDE here. Okay, I will paste this code. Now we will build and redeploy the backend app to Cloud Run. Okay, so the URL is created. We just click into it. There's no difference with the previous one, by the way, the URL. It says service unavailable. This one is the previous URL that we get, and it's still showing some message, but now it's already become service unavailable. Well, we will move on to the task 6, Now that you develop and deploy your backend app, Vertex AI Search component and a reasoning engine agent, you can now begin to design and build the Flutter front end. The Flutter app enables the user to discover more information about photo which they upload in the app. The app integrates with Gemini to generate response about the photo and uses AI agent to provide response using a chat interface. Before you develop the front-end app, you need to define the structure of the response that are returned from the Gemini 2.0 Flash model. This model is used by the AI agent that you deployed earlier in the lab. Okay, in this task, you will prompt the Gemini 2.0 Flash model and view the model response in JSON format. Gemini 2.0 Flash is available in Vertex AI Studio in the Cloud Console. So if you go to the create prompt, maybe just go to Vertex AI. Yep, this one. And go to the create prompt. So you will want to import from the Google Cloud storage, and we will go to the bucket and select the falling water and ask what is this? Okay, so this is good. Now if you want to change the response, you can do that by clicking the edit here and type in more. So you can view the JSON response that is generated by the model. You now have a prompt and model response in JSON format, which we can use to build your Flutter app. You can in the task 7, we're going to deploy the Flutter front end app. Now that you have the structure of the data that is returned by the model, you can build the front-end app. Flutter is an open-source multi-platform app development framework. It lets you write one code base that runs on Android, iOS, web, macOS, Windows, and Linux. Flutter apps are developed in the Dart programming language. For the purpose of this lab, you will use web as the target platform, so that Flutter app can be deployed as a web application and accessed using a browser. So back to the IDE terminal, that one. So we will download the Flutter app code. This done, and now we will fetch the app project dependency. Okay, so you can open the folder. App, yep. Click OK. Cluster order. So let's review some of the files in this folder. In the Explorer, click the app lib model. This one, model. And then you will find a file called metadata.dart. It will contain the data model that is used by the Flutter app. So the metadata object attribute map to the JSON attribute that are returned in response from the Gemini API. From JSON method, initialize the object attribute with when it is invoked. So in the Explorer menu, we're going to go to the so this is the main Dart. Okay, so we also can take a look at the routing Dart. So the code in this file defines the //chat setting. Flutter uses the concept of widgets, which are declarative classes that are used to build the app. In Flutter, you create a layout by composing widget to build more complex widget to form a widget tree. Okay, so we'll also take a look at the app lib UI screen quick ID .2. The file contains the classes that build the app widgets. It includes the class generate metadata screen that build the app main page and is invoked from the /path that is defined in the routing Dart. The UI let the user upload an image from their computer or mobile device or take photo from the device camera. Other UI screens that are used in the app are setting, and in the chat page we are implemented in the settings start and chat Dart files in the app lib UI screen folder. During app initialization, the Vertex AI Firebase Dart SDK is used to fetch an instance of the Gemini Gen AI model that will be used by the app. This is implemented in the _generate metadata screen state class. After the user select the image, the app invokes the Vertex AI Gemini API with the image of a text prompt. The text prompt used the same as that you tested in the earlier task, where test driving the Gemini 2.0 Flash model. That's it. Okay, all good. Now we're back to open the terminal. Okay, so first we will activate the Flutter Fire CLI package. It's done. Now we will register Flutter app with Firebase. Okay, so all of that we don't want, we just want the web. Enter. So now the Flutter, we need to configure the Flutter app chat feature. The Flutter app has a chat feature that lets users to find out more information about the image that they uploaded in the app, or request information from other external data sources that might have more updated information. To do this, we need a way to connect or ground the Gemini model to those data sources. To implement this feature, the Flutter app integrates with the reasoning engine agent that you developed earlier in this lab. Integration is achieved by connecting the Flutter app to the endpoint of the backend app that you also built and deploy to the Cloud Run. First, we will fetch your Cloud Run endpoint host name of the backend app and store the value in an environment variable. Okay, so this is the command. And then for the Flutter app, the backend app endpoint is configured in the application lib config.dat file. We will need to update the configuration entry in the file. So to verify the change, right, we can go to Explorer menu and open the config.dat file. So you verify your Cloud Run host. Is it the same as the one that you have? So we're going to deploy the Flutter app. So first we move to that folder, app folder, and then run the Flutter pub-get. And to build the project and start the web run using the FWR. Okay, open in browser. Yep, so you can test the Flutter app if this is working, but in my case it is not working. So I will just end the lab over here. Thanks for watching.